What really attracts me is this potential and opportunities to integrate new technology, and that's another part of the evolution we're seeing in this industry. I see the future will be machines will be connected to each other, sharing kind of a cloud system, where one part of the process will say people are often scared like AI and robots is going to replace humans. Some industry they will do it, and some are already doing it.
Hello, how are you?
Hey, how's it going?
Pretty good. How's your day going so far?
Pretty awesome.
Yeah? You think it's a little early for a podcast, or it's just right?
It's just right. I usually wake up at 7 a.m.
7 a.m.?
Yeah.
That's all right. It's not bad. Well, I'm going to introduce you. This is Diego Bredo, engineer, PMP, and he is currently the director of applied artificial intelligence at BID Group. And I think, at least today, I think this is going to be a really interesting conversation because when he said he applies AI, you would be very shocked by what that means. And that's one of the reasons I wanted him on today, because I think this is going to be a really interesting conversation. So thank you for joining us.
Yeah, thanks for inviting me.
So one quick question is, how did you get into AI in the first place? Like, why did you choose this career path?
So my background, I'm a forest engineer. I graduated 12 years ago. Then I started to go to the academic path. I did my master's degree. Then I switched to go to industrial process, the wood transformation. So I started working for BID Group Technologies, and we're the leader suppliers of integrated solutions for sawmillers. So people that buy logs in the forest and will transform to cut them down and get the boards that are used for construction. Right. And ever since I started working for BID, we were already using some pretty advanced technologies to grade the lumber, analyze some visual and geometric aspects, but we were not using AI deep learning in the beginning.
Right.
So I started in this field, working for this company, working on machine learnings, which is kind of subset of AI.
Right.
And then since 2018, we switched to AI deep learning, and that's where magical things start happening.
So before you even get into that, why woodwork? Like, why study woodwork at a high level? That's, I'm assuming even before you got into it, everyone was, and that may not be true, but everyone was kind of like, initial, what are you doing exactly?
My initial choice of academic path was a little bit random. Just like forests, I would like to understand how to plant and grow trees. So my first 3 years, I was concentrating on plantations, how to protect the environment, how to protect some.
So it was an environmental initiative. You were it was like you were very interested in protecting the environment and how that works. So that's how you got into it.
Exactly, yeah.
Okay, all right.
Then I saw there's a lot of potential to modernize this industry because it's one of the oldest industry in the world, right? We have been using wood for construction for a long time.
Right.
And what really attracts me is this potential and opportunities to integrate new technology and optimize it.
Right.
So not too long ago, people were still just cutting logs as they wanted. Humans were taking decisions based on their knowledge, but they always go for the safe side. So there was a lot of waste. And the clients start realizing, hey, this commodity is increasing in price, so we need to implement new technology. We need to go beyond just human-based solutions. So we need to use technology to help us out to extract the maximum output, minimizing the waste to be competitive. Because start popping a lot of mills, people were creating new sawmills process. They were competing each other, so they had to come up with strategies to go get the highest quality of product and dominate the market. So then I saw this potential. I saw this company that was doing this pretty amazing scanners with cutting edge technology, and I always liked technology itself. And then I discovered this whole world of programming, optimization, and then it's eventually machine learning and AI. and it's so amazing. So
So,
one thing led to another, and this is where I am here right now.
so you were saying it was supernatural.
Supernatural, yeah.
Okay, so um, so optimization of the logging industry was a big push for you once you got into it. You found out there was an opportunity there.
Yeah.
So then, what were some of the inefficiencies that were very obvious to you initially that you could speak about when you first got it? It's like, this is clearly could be improved. And
Yeah,
hopefully that gives the audience a map of the industry a little bit. You know what I mean?
yeah, exactly. Just like
Yeah.
the automobile industry, everything was done by humans. It's a production chains. You put a labor in every step of the process. And to get from log to boards, there's about 20 processes. People kind of don't know how many processes are involved into breaking down the logs, removing the bark, cutting into smaller logs, removing the boards from the logs, cutting them, grading, and then drying, and then packing and selling. And
Right.
all this process, it was all done by humans. No advanced computer or machinery was available until we started, and the other competitions as well. And then, even then, we were putting like very modest scanners in the beginning. And as the demand was growing, the client were like, okay, we need to do better. We need to do better. We need to do better. This constant demand to extract the highest quality and minimize the waste. And then when you look at the potential, it's still a cheap material. Not today, for instance. The wood prices dropped a lot, but during COVID, it hijacked to all-time high that people has never seen before. So it is a material that will always be used. And we're having some shortage, especially in Canada, due to the wood fires and all the protected areas we need to pay attention to, and the climate. The trees, they don't grow as fast as in South America, for instance, where you plant in 20 years, they're already 20 feet high and 15 inches diameter. Here you need to take care of the forest. It takes a long time to grow and be ready to be extracted and exploited. So we need to take care of this resource. And as Canadians, we need to be proud of the forest. And this is the part that kind of saddens me the most is I feel like this industry needs still more love. And now people are finally realizing it's time to invest. It's time to make sure we maintain the sustainable business. And it's not too late, but people need to take actions. And a lot of companies that I visited, I've seen some people are like, they just want to push the numbers, get the most they can get, and that's it. And some started looking, okay, can we do better, spending less money, less resources, and can we be competitive? That's where the computer-based solutions came up to be very handy, because you replace a human that sometimes is tired on a Monday morning or a Friday night, and this human is essentially taking the solutions. It's the human who's deciding each single piece in every process, what should be done by the machine. So you push buttons to control the mechanics. So say a human is not feeling well or tired or something, it's not going to take the best out of it. So there's a lot of potential to not replace these humans by machines, but install machines so the human can better work with machines, just the system. And this whole change process that is fascinating, because you need to convince people their old school mentality. They have been doing this work for 20, 25 years, some, before they go on retirement. And now you're coming and say, hey, it's not you who's going to take the decision anymore. It's a scanner using computer, using artificial intelligence. You're just going to assist it and make sure it's doing its proper job. So people are like, what? I don't trust it. It's never going to be as good as me. But he ended up being much better than the humans, because, like I say, he can work 24 hours every day. He doesn't think about his girlfriend or going out on a Friday night. It's constant accuracy.
Nice. So you spoke about the scanners and that as being sort of a huge advantage in the process. So the assumption is the scanner is doing something a person would have been doing, scanning for something a person would have been scanning for. So can we talk about what that is and how it's able to do a better job than a human?
Yeah, so when we say the word optimize, we're trying to find the best solution for every single piece that will be scanned in our scanners, and we need to take a decision. So start with a log. A log, it's never perfect, like a conic. There's always some defects. It goes like deformation and stuff. So you need to scan, find the best solution, close to 1/8 of an inch, to cut it out, remove the defects, find the optimal solution. A human cannot make all those calculations in a matter of 50 milliseconds. But scanners can, because we have all the data. We map the whole geometry of the piece. Then we have vision cameras that will scan, and we can detect where are all the defects that we can see on the image. So we size them perfectly, and we measure, and we can take all the trials to find the best solution possible. A human could do it, but it would take really long time to do it. And in a production chains, you don't have much time. You need to take a decision. And there's a few items coming. You need to take a decision. So you barely have like 3 seconds. That was the time a human would grade, say, boards like 2x4s would take. Okay, I have 5 grades, and each grade has some characteristics must respect the amount of defects, how pretty is the lumber, etc. So the human would need to remember all these rules. What makes a number 1? Oh, it's this, this, and that. What makes a number 2? And you have to calculate every single piece. And in one shift, he could grade up to 50,000 boards. So do you think someone can be concentrated and take decisions 50,000 times with the same accuracy? For sure, sometimes the human would be tired. Labor would be like, oh yeah, I can't do this job anymore. Just do whatever. Because there's so many pieces coming.
50,000 is a lot of boards.
Like, yeah, it's fine. It's just one board. I'm going to reject or not do the best job, right? But a scanner will do a constant, reliable job, and it's always better than a human decision.
Right. So, and is this something that's integrated into the bigger machinery? Or is this someone who is standing over the boards as they go through, scanning them?
No, it's static scanners, and you have chains or conveyors that will push logs or the boards or other parts of the logs that we cut down, and will be scanned. It will be controlled in a controlled environment. So there's all the PLC and controls that make sure the pieces are aligned, touching the line bar, what we call it's the reference point. So we always scan the same way in a controlled environment.
So how much improvement did this sort of bring into the process? Like how much of a removal of errors did the scanners introduce?
Well, it all depends on the client's situation before he buys the scanners. But just to say, like, we can improve just 60% the productivity of a client. If they go from just labor, no machines at all, you put all scanners, you're going to see a tremendous increase in value. You're going to drop the errors, because if you make errors, you can hurt people down the way, because these lumbers, if you're not grading them properly, you go to Home Depot or Rona and you buy these lumbers and you go build your house with, but there's a breakage in the lumber, for instance, or something, and your house damaged. The sawmiller where you bought the lumber from, his job is to make sure he delivers a product that is safe for people to buy, build houses, or do other stuff with. So this job must be controlled. So we have agencies that go visit the clients to do inspections to control the quality. So it's a very controlled environment in the wood transformation. And this is very important to be grading properly and not losing too much value. So people always play on the safe side because they're scared of making mistakes and getting like people suing them like, I bought your lumber and it wasn't the proper grade, you did a bad job, so I'm going to sue you. So they're scared of it. There's this legal aspect as well. But when you play on the safe side, you tend to overestimate. So that's where the scanners come to give an excellent ROI, because you make a lot more money, but you're not making mistakes. So you start being safe and you're being accurate.
Nice. So with all this being said, how do you, sell this to an industry of this age? Because you talked about introducing new technology, especially AI, which a lot of people are getting a grasp of, even with newer industries. So how do you introduce that kind of technology to an industry that is really the oldest industry, one of the oldest industries that you could have industrialized, and has been through tons, like hundreds of years of industrialization.
Exactly.
So there's a lot of trepidation when it comes to what machines are going to represent in that industry. So how do you have that conversation? Obviously, there's an improvement, but like anything else, before you get to the person who's going to make that decision, there's quite a few conversations you have to have before that. So it just sounds tough. Like the numbers sound self-evident, but it's almost like it needs to be that in order to even get any sort of headway in that industry.
Yeah, they have no choice. Even the clients that were small sawmillers, they didn't have much cash flow. They got to a point where either they act and buy scanners, or they die and they shut down. Because the competition was so strong around them, they were killing them because they were not making enough profits to pay the whole process and continue to buy logs, because wood is a commodity, right? So it keeps...
It's a commodity, yeah.
It varies the price like a stock market. So if you go high, you got to buy the logs high, but you're going to sell the product high. So your profit margin will shrink. And then the labor, salaries, etc. So you need to innovate. So people ended up saying, yeah, you know what? I have to buy these scanners. Even though I don't trust, I buy it. And once we install, they're like, oh, damn, I have been passing by this opportunity until now because I had this preconception that a machine would never be as good as a person. But he ended up discovering it's way better. Then like, wow.
Is the competition coming? This is sort of a Canadian operation in terms of the people that you're reaching out to. Is the competition coming Is it because the competition is coming internationally?
And we do have some good competitors within Canada, United States,
as well,
in Europe. But in Europe, they have their own market. It's not the same thing. We're also have clients in all across North America and a few in Europe. But that market is different. It's mostly within North America. It's a growing market, right? There's a lot of sawmillers all spread in the globe. And during the COVID, a lot of new people decided to buy new mills and keep growing and increasing the number of sites. And it's a good opportunity. It's a good market.
Good market. Okay. Let's talk a little bit about sort of the actual technology that is powering all this. So I guess a simple question is, what are you using open source technology? Do you guys have something very specific within your ecosystem that enables you to actually do this? So where do you land on that?
So it was an evolution process, but we have really good programmers, people that are highly skilled in the programming field. So we kind of took something that was in the open library and we completely adapted this ecosystem of AI deep neural network to do our applications, because we don't do like ChatGPT. That's not the kind of AI we do. Our AI is the detect defects on the image, or detect some issues that a human can see looking at an image. So this is the AI that we deploy. We analyze vision image to identify where are the things that we're concerned, so we can properly flag them. And then with our computer algorithm, we go calculate how big it is, how wide it spreads, etc. So then we can get that input and optimize the solution for each single log or board that we're grading, depending on the part of the process.
All right. So is that TensorFlow? Is that PyTorch? Is there your stack?
Well, I cannot disclose exactly what we use, but it's kind of mixed from what you can download in the open resource, but we have to adapt because, like I said, this is a very niche application of AI. So
Right.
there's not many people out there doing this. So it's
Right.
really
Right.
hard to find this kind of stuff available to download and copy and use it, right?
Yeah.
So we
Yeah.
had to kind of base ourselves from something that exists to learn how it works. And then we put a lot of efforts to how we can do this on our applications and specialize this technology to do what we need to do.
Right. So you talked before on our last conversation about robotics and how that is affecting that industry. So could you talk a little bit about that?
Yeah, that's another part of the evolution we're seeing in this industry is, okay, now people, they accepted they need to buy scanners. So pretty much there's only a few handful clients without any scanners at all. I don't think they're going to survive much longer unless they're in specialty products where they're the only ones who make a kind of product. So now the next challenge is the labor shortage,
Is
especially in
there a reason?
Canada. Well,
Is
yeah,
there
yeah.
is there a reason they don't want to buy the scanners if the scanners are
Well,
going to
also the
improve?
price, right? It's not like $1,000 scanner. You can go to 1 million, 2 million,
It's
depending
not.
on. Yeah. It's quite expensive because the ROI is so fast, and you're gonna cut maybe 3 or 4 salaries when you buy those
Right.
scanners per year. So if you sum them up with all the social benefits, you get the payback in less than a year, depending on
Right.
the application. But then now in Canada, we're seeing this labor shortage issue where we need labor. We're hiring people from overseas. We're trying to get more employees, but it's really hard to find people that are willing to move out from the big cities to go to the isolated remote areas where the sawmills are located. They're not in downtown. So you
Right.
have the challenge of there's not many people in Canada, so our labor is short. Then the few labor that is existing, they never want to go live in up north or in a distant area unless they were born in those specific regions. So now
Right.
some clients, they used to run 3 shifts a day, so 23 hours or 24 hours with 1 hour break probably. Now some they have to completely stop one shift because they didn't have enough operators to run the mill. So this is really, really like hurting them so bad because you don't make anything during the whole shift because you don't have enough labor. So now they're like,
Right.
wow, we cannot find anyone to come. And people they hire, they stay there for like 2 weeks and they just quit because they don't like the job is monotonous. There's some risks of injuries because you're constantly manipulating heavy stuff close to machinery. So you could get hurt, right? If you're not
Yeah.
paying
Very
attention.
easily.
And young
Yeah.
people, they have different mentality, right? They want to work with computers. They want to be high tech and live in downtown. So no one wants to go, say, up to Témiscamingue, up north in Quebec or in the
Yeah.
remote
Nobody.
areas, extreme west coast BC. It's pretty places, but people don't want to work in those areas sometimes. And
Right.
now the sawmillers, they're like, we need to start looking for robots because if we cannot fulfill that position with the human, we're not going to be able to run. So we
Right.
need to pay salaries. We have a business to keep alive. So they have to now buy robots. That's why we
Right.
started this initiative offering robotics optimizers within the scene. So we use AI to detect when there's a problem. Say you're running there's a board that's supposed to be straight. And there's one board that is skewed. So it's going to cause a jam because they're going to block somewhere down the road. So AI will detect there is a problem and the robot, okay, got it. I'm going to remove it and go fix it up, remove, and you continue running. Instead of
Is that
asking for a guy to climb, remove the board, there's a risk of
right?
injury, safety aspects, etc.
I know Tesla's for manufacturing engineering. Tesla's doing or using quite a few trainable robotic machines to not necessarily do what you talked about,
Mm-hmm.
but definitely do quite a few things
Yeah.
in their factory. I don't know whether BID whether you're the company you're in is in that space as well in terms of making those or at all, or it just
Mm,
is something that you're in, that is necessary and something they're looking into. So what is that? Is that something you guys are gonna look into making, like objectively making yourselves?
So we're purchasing the robots. They're designed and manufactured by a third party, and we're
Right.
just developing the code that will do the actions and then the communications with our scanners that
AI,
will
yeah,
tell the
AI
robot.
scanners.
Yeah.
Right. So can we talk? I mean, I know you can't talk about this specific technology, but sort of talk about maybe architecture or something so that the audience can learn about, if they ever got into this industry, what it would mean to write for or code for some of these solutions. Because I think a lot of people, when they hear robotics and AI, it's, so there's a certain kind of person that's very excited to,
Yeah, yeah.
to be able to play with both those things. So it'd be great to hear sort of what are the challenges and some of the ways in which in architectures and things that you're building and some solutions
Uh-huh.
uh, or problems that you have because you're trying to sort of merge these two things together.
Yeah, exactly. So
Yeah,
first things first, you need some highly skilled programmers because they're the core of this technology, right? You need to get someone or a crew that knows how it works, machine learning, AI, deep neural network. It's not that complicated because, like I said, you can download some open resources stuff, and you and me, we can start doing some AI on our computer just by downloading very light software. You just need to understand the basics of programming. Some people do with Python, one of the simplest programming language out there, and it's the best one for AI. And I know Google, Microsoft Azure, they just launched their machine learning portal. So you kind of can, if you don't have time to do that or don't have the resources, you can also um, go see people that have this structure and you rent their machine and you just upload your data and it's going to analyze for you for at least testing purposes.
right.
And then you need to have this whole server structure with all the computers, the GPU, graphic processing units, cards. That's the feel for AI. This is what's gonna give you the power to crunch the data, build your
Right.
models, and then to run live predictions. Because you need first to train, and that's the biggest challenge is the data. Uh,
So did you, for this particular situation, were you at a factory capturing information
yeah,
and then using that to filter through? And is that set up? Because another thing is because of sort of the nature of this, the continuous improvement cycle can be sort of infinite because as it's training, as it's working that training, it can continue. You can have a camera there that consistently just takes pictures, and you
yeah.
can error check
Or
against the AI itself, and it can just like sort of train itself and infinitely improve. Um, so, which is just sort of more of an idea, but for how you started it initially, was that how that happened? You just took picture. You went to a mill, asked someone, "Hey, we're going to take pictures of all your boards," and just like
so the our
send that
advantage
information over.
because our scanners that we have been selling since 2008. This is one of our biggest product that we sell out there is the auto grader. It's the machine that will grade the boards and give the
All
perfect
right.
optimal solution for every single 2x4, 2x6, etc. that is scanned. So we already have all these images because we were using conventional programming to detect all the wood defects without AI. It was really hard to achieve excellent accuracy. We were doing pretty good, but
Yeah.
there was some room for improvement. So that what leverage our success is we already have this whole ecosystem with all the optimization scanners, the vision acquisition image. So we had all this huge data set available for us. We just have to, okay, how we can take this image. We need to build an in-house program to train the AI, show those images. Okay, in this image, I need you to identify this knot or this opening in the wood. So we would identify and then need to build this architecture to train the model with these images that were tagged by a human.
Okay.
So it's
So
it's a process, right?
no, no, absolutely. So what is, I'm actually now interested in what was the, what was the solution before AI? Like,
Oh
what
man,
were the algorithm?
it was really complex.
Yeah.
Thousands of lines of code. 1,000. Because because we have a line scan camera. It's not like a snap camera. So you collect every line. There's a RGB colors, and you merge them and you have the full image. So it's really good resolution that we have. So you can clearly see the piece of lumber. You can see all the natural defects that are present. And you as a human grader, if you have gone through a training, you would be able to grade that lumber most likely just by looking on the image. Sure, you need to get your measuring tape and measure stuff, but you could look, okay, that board, it's a number 1 or a number 2 because of that defect. It seems to be too big, etc. So you have a pretty good image of what you need to do, right?
Oh, and what is the number 1 and number 2 defect? Is that
number 1, it's a number 1 grade. So there's a set of criteria that says you cannot have oversized more than half inch. I'm just saying numbers. Or a split that open. It cannot be more than a third of the length. There's a bunch of rules because people that came up with those rules, they ran a lot of testing to test, okay, amongst all these wood natural defects, how far can we go until the board, it's not safe anymore? And if you put weight on it, you put load, it's going to stress. You're going to rip it off the fibers and break it down. So they have to come up with rules saying, okay, until you can go up to here to be acceptable in that grade of lumber. And then you go to number 2. And if you exceed that parameter or that kind of allowance, you go to number 3. And as you go down, the quality deteriorates. And then it's just for fencing or building trails, railways. You cannot build houses anymore. It's just number 1, number 2. And what they call the MSRs is the machine structure. You kind of measure the MOE, the module of elasticity of the lumber, how much you can bend until it comes back up. So there's a bunch of calculations you need to do because...
But you can tell that just by looking at it? You can tell the MOE by looking at the lumber
we have a machine, a little hammer that will hit the lumber, and by resonance, we're going to measure how fast it goes, so you can kind of deduct what is the MOE, is the module of elasticity.
Okay.
So it's a coefficient that you measure to see this lumber is strong enough to build a house or it's not strong enough.
Going back, can your scanner detect that somehow?
No, you need a sensor that will measure.
You definitely need a sensor.
Yeah.
Okay, got it. So going back to the original way you guys were working on it, you would take these RGB colors where you could actually, to some degree, see some of what you need to actually grade it. There's other things that in terms of like physical properties that is tough, but in terms of defects specifically, at least you can say it's at the upper or lower limit based on the images that you are collecting. So then how would the machine be able to tell, hey, this is, because is it testing against what you consider to be perfect? And then it's just all these categories of things and you're just checking for if they exist or not computationally just by checking where in the image can you find something. So just marching down color, marching down the image and looking for defects, basically, computationally.
Exactly. For every pixel in the image, we would have its intensity for red colors, green and blue, and the average intensity. So each pixel had a value. So we were trying by a bunch of parameters to say, okay, a knot, every single knot on the board, it's usually between 70 and 80 intensity, and the rest is sound wood. So that's how we would flag these pixels to say, okay, that pixel is most likely a knot. So we'd have a cluster, then we'll do a lot of processing to kind of box it out without AI. And it was working good. The only issue was when some wood species, because there's a lot of different wood species, the sawmillers, they cut. Some do lodgepole pine, all others balsam fir or hardwood for flooring. So it depends on the appearance of the lumber, the color intensity, the challenge would increase because it wouldn't be that easier to separate perfectly. Okay, these pixels are a defect and these are not a defect. And that's where we realized we need something else than just trying constantly to change parameters. It was a constant changes because the customer would call, hey, my lumber I got from a different forest, it has a different appearance. We need to adjust the scanners. So it would be a lot of resources, a lot of time put into, okay, how we can adapt our code for this kind of image right now. So we'll change. And then with machine learning, we start seeing some really amazing gains. Like, okay, now we can kind of cluster the image into specific groups, and the system will try to do itself on its own. But it wasn't perfect because it hasn't the deep neural network. But when we put this last subset of AI, that was when the magic things happens, because you only got to do is train the system with a few images, and it will learn and it will reproduce what it learned, and it will be so accurate. It's just amazing.
Yeah, it is. So moving back to how this actually how you guys actually are able to tie this into the robotic system. How does that overlay? How would that work, right? So you've talked about where it was before, what it is now. Now you're going past this sort of deep neural network part to like making it into something that is actionable by itself and actually, not just reporting results. So how hard is it to get the robot to behave based on those images? Is it?
So our strategy right now is the robot doesn't have any sensors. Our robot, it's only the arm or the equipment that will place something or pick something up or remove something. So we use cameras, vision cameras, or a scanner that will give the robot the locations, the coordinates, X, Y, and Y. Look, this, take it, that piece right there. So the robot is calibrated. He knows his intervention area. So he will, okay, you told me to go to this location right here. Okay, I take it. So the robot doesn't do AI. AI is done by something else that will feed the robot with the output. That's our strategy.
You're just sending it location information.
Yeah,
that's pretty much it. It's just an arm. You're not giving it any sort of. You're not giving it a brain. It's just acting as an arm.
Exactly, but they need each other to do the job, right?
Yeah, absolutely. Yeah. So, so it sounds easy in the way you presented it, but are you having challenges in making that happen? And I like anything else. I mean, you've done some truly amazing things so far, and it's very interesting to see how you've been able to really accelerate this solution to a point where the identification is no longer an issue. But then I'm sure there's still more challenges in getting, or what are the challenges in getting that arm to, because you don't want it to pick up the wrong piece, and the pieces that are defected that you sliced off and which you spoke about initially, those are very hard pieces to pick up because they are small, and that was the goal is to make them smaller and smaller. So it has to be better. As both systems improve, that arm, or I suppose as the AI improves, the arm has to be better at picking up a smaller piece, and that kind of dexterity for a machine is difficult. And so there's a adversarial behavior there in a way, where one is bounded by the other.
Absolutely, we have challenge all the way, and every time we encounter some new issues, and we kind of like it because it pushes us to okay, we have now another issue. How can we fix it? So now it forces us to understand even better the technology, because when everything is easy, you're like, okay, I mastered this technology. I don't need to do anything else. But that's not always the case. There's always this challenge that shows up. Oh, yeah. Is the AI going to be able to distinguish the situation from everything else? We don't know. Let's try. So then we try like, wow, he managed to do it. It's cool. And the robots, we just started. We have 2 systems installed, and we're still work on it. It's working good. There's still, like you said, when we test stuff, we think, okay, we place in our test bench. We have a little production line in our office, so we train the robots to go pick it up, the skilled boards and stuff. It was easy because we were making them. But when you go in the real production, all kinds of scenarios can happen. It's never predictable. You can find one piece in a specific position you did not think it would happen, and it did happen. So now we need to train the AI to see that, and train the robot to go like how he can reach out to that piece, remove it without disturbing the others and making more mess. It's just supposed to help it out. So there's always this challenge. And like you said, with more data, it's going to get better. With the more applications, the more testing, it will just improve. So it's always a growth, right?
So, and what it also sounds like if it picks it up or moves something the wrong way, you can shift the board to the point where it can make it so that the machine is stuck later down the assembly line.
Mm-hmm.
So it's not just like being able to pick it up and, like you said, shifting things around. Like you have to make sure that doesn't happen either. So there's sort of like there's another sort of angle to it where it can stop the production line. So that can make it really, really tough.
Exactly. Yeah. So you need to maximize the productivity time of the client and not create more downtime.
Yeah, exactly. No, not more mess.
Both ways. And the two issues to make sure like you detect the issues and you don't create something that doesn't exist.
Exactly. Yeah, it also sounds like your initial way that you were building, which is tweak for recognition, you kind of have to now do that for the robot.
Yeah, it's going to be all over again because it's a new technology. We need now to give not only the locations in 2 dimensions, but also 3 dimensions, because if there's one piece over each other, you need to be able to tell the robot, hey, buddy, is the piece that is above and needs to pick up. Don't pick up below. So that's going to push us to improve our capabilities because now we need to use other sensors to help out, not only a 2D cameras, right? Because you need to have the depth data. So that's where we're going to have to, again, do some research and we're moving forward with it. So it's going to push us to improve again because it's a new challenge.
What do you see this industry is going to be in the next few years, given that you're sort of the one pushing it forward?
Well, I see the future will be machines will be connected to each other, sharing kind of a cloud system where one part of the process will say, I'm making more than usual errors or there are too many waste. There might be something wrong with machine number 3. So it will send a message saying, hey, buddy, I think your saws are offset. Do like a tweak and automatically will readjust based on the output is getting down the road. And all this, they're all using AI to analyze, to do their job. Plus cameras, they're monitoring the whole area to identify production anomalies. And the machines are communicating to one another. And there's also, for sure, operator that will probably be required to confirm because you don't want to leave a mill fully automated, taking all decisions based on data, because what if it's a bad decision, it can really screw your production. So we kind of believe in the
down very quickly.
It's just people are often scared like AI and robots is going to replace humans. Some industry, they will do it. And some are already doing it. There's no humans at all. It's all robots, all computers. But you need to look at the pros and cons, right? If your industry is not that well controlled, there's always stuff that can happen. You're better off having an operator that will assist the machines and say, yeah, your decision is right, because sometimes you need to interpret what's happening. You need to take your discretion analysis and say, hey, this situation, it's not good, but I know if I change it now, it's going to cause even worse issues down the road. And that AI could learn too. But what if you make some mistakes and you're relying your whole production on machines that will communicate, interchange information, and change parameters? If it's not right, you're going to screw your production, right?
Right. And especially in these remote areas that nobody wants to go to. So
yeah, right.
You really need to make sure it's as close to, and from a structure perspective, as 100% and foolproof as you can.
Yeah, absolutely.
So, sorry.
I'm going to cut that out.
But you know what? Thank you so much for joining. I really do appreciate it. I learned quite a lot. Who would have thought the oldest and newest put together? It's, this is not something anybody would have imagined. Right?
I know.
And it's so interesting where you can see sort of that juxtaposition. And also this, like, I can't even imagine the kind of conversations you're having with people, like the cultural clashes are, you know, even though it's something that obviously improves things and that sort of pushes things forward, but that sort of the cultural clashes and conversations and sort of outcomes that you're always being a part of, and the kind of person you need to be to have those conversations must be very interesting in this industry, right? So thanks for sharing some of that with us. And
Yeah,
where
my
can people
pleasure.
find you if they want to learn more or be part of this?
Yeah, so they can always reach us on LinkedIn. If there are some potential people that see if we could help them with our technology, they can reach us out too. We're always open to new projects. We're trying to, we have this niche in this industry, but now we have all this expertise and experience. We're looking forward to how we can leverage this technology's expertise to sell new applications outside of the lumber industry. So this is probably where we probably will be going within the 5 next years.
Well, thank you so much, and I hope you enjoyed it.
Yeah, thank you.
So how do you, it's done.
It's done.
So how'd you like it?
Yeah,
How'd
it's
you
really
feel?
fun. It's fun. Yeah.